Dear students, today we are learning how to read important features of graph. By the end, you'll be able to find maximums and minimums, x and y intercepts, also called zeros, intervals where a function increases or decreases, and how to read solutions from a graph. We'll also practice with a piecewise function and a real-life rocket graph. So let's get started. Alright, so the first question asks us to find f negative 2. Remember, this is x negative 2. So we go to x negative 2 on the axis and we find what y value the graph has there. So f negative 2 will be here, f negative 2, go to x negative 2, look up to the graph and then find that points y values. So y value is here. So I can get that my y is negative 3. So this is negative 3. F8, go to x8. x8 is here. And then look up the graph. This is our coordinates of y. So y is 3. Next, f negative 8. Go to x negative 8. Negative 8 is here. And then we know that our y value will be negative 3, 2. And then f4, go to x4. x4 is here. And then we'll find our y, which is negative 1. Okay, so question A, when we evaluate a function, we are reading the height of the graph at a certain x value. B, asking for relative maximum and minimum values. So a relative maximum is a high point that's higher than the points nearby. And then a relative minimum is a low point that's lower than the points nearby. So first we scan the graph from left to right. When the curve goes up then down, that's the relative maximum. When the curve goes down then up, that's a relative minimum. So you can see from the graph, relative maximum goes up then down at negative 6, 2. Negative 6. This is negative 6 and 2. This is our relative maximum, or we can say that the highest peak. And then here, 1, 4. Okay, maximum, relative maximum, we have 1, 4, and negative 6, 2. 1, 4, negative 6, 2. Relative minimum I have here, negative 3, negative 4. Minimum. The other is here, 4, negative 1. So I will list down my relative minimum is 4, negative 1. So there are 2 hills and 2 valleys. Each hill is a relative maximum. Each valley is a relative minimum. Then question C asks us about absolute maximum and minimum of the function. At what x values do they occur? Okay, so absolute minimum means, absolute means the very top or the very bottom of the whole graph, not just locally but overall. So do it slowly. Look at all y values we found here. Which is the highest y on the entire graph? That's the absolute maximum. Which is the lowest y on the entire graph? That's the absolute minimum. So from the graph, I can see the highest point y is here. The highest point, y4, at x1. So we can say the absolute maximum is x1, y4. So highest point y4 at x1, so absolute maximum. Lowest point at here, -3, -4. Y -4 at x, -3, absolute minimum. So absolute means biggest. Absolute mean biggest or smallest value anywhere on the graph. For relative maximum and relative minimum means high point, like how many points that we have the peak one, and then relative minimum means low point, that's lower than the points nearby. So I can see we have actually two coordinates for maximum, relative maximum, and two coordinates for relative minimum. Next question asks us for in x-intercept and y-intercept. Intercept tells us where the graph crosses the axis. So for the look for every place the graph crosses the x-axis where y equal to 0. X-intercept means y equal to 0. So when y0, this is y0, right? This is the line of y0. I can see that my points or my, I can write like the order of this coordinate is, x is 1, 2, 3, 4, 5, 6, 7. 7, 0, and this is 5, 0. Sorry, this is negative. At the left side, -5 and -7. And then this is -1, 0. And then this is 3, 0. And then this is 5, 0. This is our x-intercept. So I list down. And then y-intercept is when x is 0. So this is when x 0. This line is when x 0. This is the only line when x 0. So I need to find where the graph crosses the y-axis, that's x 0. So then I read the value of y. I only have 1, which is x 0, and y is 3. So I list down the coordinates. A function can have many x-intercepts but only one y-intercept, because when x equals to 0, you can only get one y value. Then for E, give an interval over which the function is increasing, give an interval over which is decreasing. So from the graph, find where it goes up. The graph rises, go upward. You can see that from x -3, this is x -3 to x1. So from here to here, okay, we say that graph rises or goes upward from x negative 3 to x1. So I can write down the interval like this. Okay, from x negative 3 to x1. And then graph goes down from 1 to 4. So 4 is here. So you can see that decrease using pink color, 1, 2, 4. And I can write my interval like 1, 4. From 1 x equal to 1 to x equal to 4. It is decreasing or falls or goes downward. We only use x value to describe interval. To describe interval, we only use x values, never y values, to describe interval. Okay, then F. Use your graph to find all solution to the equation fx equal to 3. The equation fx equal to 3 here means that we are looking for every place on the graph where the y value equal 3. So just compare from the original equation, fx is equal to y. So from here, fx is equal to 3, so our y value is 3. So the number 3 represents the height of the function, the y value. So we are searching for all points on the graph where the height is 3. So here, when y is 3, we draw a line. Imagine a horizontal line across the graph at y equal to 3. The line is parallel to x-axis. Wherever the curve touches or crosses that line, the y value is 3. Those are your solutions. So look at the graph meets that line. Read the x value of those intersection points. So I have here, here, and here. So you can see here the coordinate is actually, this is x0, so 0, 3. Here is 2, 3, x2, y3, and then here x is 3, 4, 5, 6, 7, 8. So 8 and 3. So our solution is 0, 2, and 8. So when y is equal to 3, my x is 0, 2, and 8. So for f, means that when x equal to 0, 2, or 8, the height of the graph is exactly 3. If you check the graph, you'll see circles at those points. These are the solution to fx equal to 3. And then G, if the function positive or negative on interval from here, x negative 1, 2, 3. So where is x negative 1, 2, 3 from the graph? Now we are not finding a specific number, we are describing whether the function's y value are above or below the x-axis. So negative 1 lesser than x lesser than 3 means we are looking only between those two x values, negative 1 and 3, not including negative 1 and 3 themselves. So negative 1 is here, 3 is here. Is the graph above the x-axis or below it in this section? So between negative 1 and 3, the graph lies above the x-axis. The function is positive on this interval. You can see this is the line from negative 1 to 3. A function is positive when it's above the x-axis. because the y values are positive. If it's below x-axis, it's negative because the y value are negative. Now you can see that y value is actually here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, right? So all is positive y value. You can quickly check that if it is above, the function is positive, and it is below, it is negative. In the graph, the function is between -1, 2, 3, but look at the part around -5 to -1. If I say x -5, -5 will be here. -2, -3, this is -5, -5 to -1. So if question asks an interval for this one, if this is just an example, that part is below x-axis, so it's negative there. The function is positive because it lies above the x-axis. An example of negative section is here. This is negative. This is positive. Okay, for 1G, you can write down the function is positive because it lies above x-axis. An example of an interval where the function is negative would be -5, -1. Okay, for question 2a, find the highest point on the curve, maximum height. So first scan this curve from left to right and find the topmost point, the peak. So you can see that you need to read its height from the y-axis here. So that's the maximum height. Read the matching time from the x-axis when it happens. So here maximum height is y is 190, x is 6 x is, this is 6, this is 7. So you can see that it is actually at 6 seconds. So 6190. So you can say that maximum height is h equal to 190 meters and t is equal to 6 seconds. So remember that highest refers to largest y value, not largest t. How many seconds for B? How many seconds was the rocket in flight? So the rocket is in flight from launch, leave the grounds until lands, return to the ground. So find where the graph starts on the ground. First time it touches x-axis 0, here, t0. And then find the graph where returns to the ground. Last time it touches the x-axis, that's t equal to 12. So flight time will be landing time. Flight time will be landing time minus launch time. It is 12 minus 0, which is 12 seconds. So for CH2 equal to 90 means that this is time t equal to 2 seconds. And then this is y, right? So height is 90 meters. So this is when we input the time 2 seconds and we get the output height 90 meters. So we can just look at the graph. This is when t2 or x2. When I go up, I get my y is 90. My coordinate is 290. Okay, D, decreasing. Decreasing means the height goes down as time move forward. To find the decreasing, you need to look at the curve. It rises until the peak here, until t or x equal to 6. And then after t equal to 6, it falls down. It falls down. It falls all the way down to the ground T12. So height is decreasing from T equal to 6 here to here, to T equal to 12. So you can write down 612 or 6T12. We include 6 because that's the peak where the going down starts, and include 12 because it keeps decreasing right up to landing. The height is decreasing on 6, 12. Alright, so first we pin on the graph to the page by plotting the points it must go through. Plot negative 8, 0. So this is x and y. Negative 8, negative 2, negative 4, negative 6, negative 8. Negative 8, 0 will be here. 5, 2. So this is 2, 4, 6 of 5 is here, x5. And y negative 2 is here. Negative 2. And 8, 3. So this is 8, x8, 3, y3 should be here. This is y3. So I already have my 3 points. Okay. And then question has an absolute maximum at f negative 4 and y 5. That is the absolute maximum. So go to, this is x, this is y. So negative 4 and 5. Negative 4, 5. Y will be positive 5. Should be here. And then minimum x, y, coordinate is 2, negative 6. Absolute minimum. Absolute minimum 2, negative 6 will be here. Negative 4, negative 6 should be here. Okay, I already have the absolute maximum and minimum. Absolute maximum, remember that this is the highest y value on the graph. Noting that we need to draw up to y. Yes, we already done. This is 5. And then absolute minimum, we also already plot it. This is lowest y value on our graph. So we already draw it at negative 6 y and x equal to 2. Okay, and then decreasing on interval negative 4, 2. So from negative 4 here, I will just using orange color, mark it using orange color, and then 2 here. It is decreasing on the interval from negative 4, x negative 4 to x2. As we move right, the graph height must go down the whole time, no bumps up in the middle. So starting at the maximum point, negative 4, 5, your curve must descend steadily until it reaches the minimum point 2, negative 6. Okay, so from this interval, saying that it is a decreasing interval. So I know that from negative 4 to 2, it will go down like this. So we will just match all the points, and then that's it. So this is my graph.